Now, one of the issues with CDMA is clearly that everybody is talking at the same time, the same frequency band. In other words, the frequency reuse vector is 1. And how do we deal with the resulting interference? Interference in the air for cellular network is the first example in this course of something called negative externality. Externality here, roughly speaking, refers to the fact that your happiness also depends on what other people do. Okay? Your signal, your cup of tea or coffee, is other transmission's poison. And this is what we call a negative externality. Now, we will also later look at positive externalities in social and technological networks. Sometimes people also call this the tragedy of commons. In a later lecture, we will talk much more about tragedy of commons and how to deal with that in social and technological networks. Now, one famous special case of interference in the air is so-called near-far problem. If we go back to this picture, you see that a mobile station A is much closer to the base station than mobile station B. Okay? Your neighbor, or your friends, let's say, your friend's iPhone might be much closer than your Android phone to the base station. Maybe your friend is sitting right beneath the cell tower, the base station. And therefore, the distance it traverses is much shorter, and the signal received at the base station is much stronger than yours. And it can drown out your signal. And that is what we call the near-far problem. The near user will overwhelm the farther away user's signal. Now, there was a simple solution provided by Qualcomm in the late 80s that uses the idea of feedback control. Now, later we'll see much more complicated feedback control in a network. In this case, this is a simple one hop from the base station to different mobile stations. The degree of freedom here is exactly transmit power. Okay? And it says that, well, adjust your transmit power based on where you are. It's going to estimate first the channel condition. For example, how much channel loss does your signal suffer? And then it would reverse that. Say if your channel loss is a factor of 2, okay, and the other is a factor of 0.9, for example, okay, then I will tell you, look, you should multiply your signal strength by a factor of 2, and you should multiply by a factor of 1 over 0.9, which is much smaller than 2. Then this power adjustment would cancel out the effect of the channel attenuation, and then I will have equalized received signal power from both of you at the base station. So this is a simple algorithm. There's no iteration, okay? And it is through a central command by the base station. And it suffices to achieve equalization of received signal power. And without this feedback control to take up the near-far problem, you will never be able to implement CDMA because the amount of interference would be just too much. Now, what if you need to achieve a target signal quality which might be different for different mobile stations? Not just simply equalize all the received power. And that was the challenge in the early 90s.